Okay, so now one of the craziest things about the natural exponential function is that it's actually its own derivative. So what does that mean? Well, it literally means that if you take the derivative of e to the x with respect to x, the derivative is e to the x. So the derivative of e to the x is e to the x. That's literally what it means. And you can apply that to, a composite function. So if let's say you have e to some other function, so e to the u, you just got to use chain rules. It's e to the u times du dx. So it's a pretty convenient function because the derivative is really easy to find. So we're going to be practicing that. But let's first look at the graph so you can make sure you understand geometrically what's going on here. So we have the the natural exponential function y equals e to the x. So what this is saying is that it has a we know this graph has an intercept at 0, 1. So the derivative at 0, 1, in other words, the slope of the tangent line here, so y prime, what would y prime be? Think about it. What would y prime be? This slope here. Well, y prime would literally just be the y value here. Y prime would just be 1. Because again, the derivative is just the same, is just itself. E to the x here is 1. So the derivative of e to the x at this point is just also 1. Let's pick another point. Let's say, a point up here. Let's say at 1 comma e. And again, we're looking at the tangent line. What would the derivative here be? Well, again, the y value here is e. So the derivative at the point 1 comma e is just going to be e. It's literally this, again, it's the same value of whatever it's just its y value at whatever point we're evaluating at. So let's go through some actual calculus examples so we can really understand how to deal with this. So we're going to differentiate each of these, and let's see what we got. So first we have f of x is equal to e to the x. So this is as simple as you can get. This will just be that f prime of x is equal to e to the x. There's no composite function. It's just x. So that's all you got to do here. Here we have a composite function. So we have a u like, let's say 2x minus 1. So then what would f prime of x be? So let's rewrite this. If it helps, remember, let's rewrite this as e to the u. Well, again, all you got to do is you always keep this in your answer. So it'll be e to the u times the derivative of u with respect to x. So times du dx, or just take the derivative of the 2x minus 1. The derivative of 2x minus 1 is just 2. So this is literally just going to be equal to e to the 2x minus 1 times 2. And we'll just put the 2 in front because that's how we like it. And that's it. And C, we have f of x is equal to, let me write this a little clearer because it's a little small, equals e to the negative 3 over x. So negative 3 over x is your exponent. Now, what we got to do is, this is always going to be in our final answer. That's what I first advised. So f of x, or f prime of x, will be equal to e to the negative 3 over x. This will be part of your final answer, but we got to multiply it by the derivative of this. And then remember, negative 3 over x, let's rewrite that. Negative 3 over x is the same as negative 3x to negative 1. That's probably a little easier to understand. So the derivative of this is just negative 1 times negative 3, or 3 times x to negative 2. And so all you got here is then this is going to multiply this by 3x to the negative 2. And then all you got to really do is simplify this. So this will look something like, the x to the negative 2 will be in denominator because that's how we like to write it. So this will just be 3e to the negative 3 over x over x squared. Okay, now let's go through a more involved problem involving the stuff we covered in chapter 3. Let's find the relative extrema of f of x is equal to x times e to the x. So remember, to find relative extrema, you essentially want to find the minimum or maximum, or local minimum maximum in this case. And for that, we have to find where the derivative is undefined or where it's 0. So first, we have to find the derivative. So f prime of x is equal to, so here we have we have a product rule. We have x and e to the x. Those are our two functions. So remember the product rule. We take the derivative of the first guy, multiply by the second guy, add it to the first guy times the derivative of the second guy. So the derivative of x, which is 1, times e to the x, plus, now we hold x as is, times the derivative of e to the x. But again, that's just going to be e to the x. That's all that is. And so then this is really just our derivative. The derivative is just e to the x plus x e to the x. But now we got to find where the derivative is undefined or 0. We got to find critical value. So where is f prime of x equal to 0? So we're going to set 0 equal to this. And you can factor out e to the x from each of those. This becomes e to the x times 1 plus x. And the only solution for this would be from 1 plus x equal to 0, because e to any number won't ever be 0. So we have 1 plus x equal to 0. And so a critical point would occur at -1. And it's not undefined anywhere else. This is defined for all real values. So this is our only critical value. Critical value. So we have to study what's going on around here. So remember, let's draw, I like drawing a little interval. Want to see what's going on at -1. Let's put this in blue. And then we want to, let's see what's going on before -1 and after. So let's put -2 and a 0. Because you want to see what's the sign of the derivative over here. What is f prime of x going to be at -2? And what is f prime of 0 going to be? So f prime of -2. Remember, we only care about the sign. F prime of -2, we plug it into here. We'll have e to the -2 times 1 plus -2. So e to the -2 times 1 plus -2, or 1 minus 2. So we have -e to -2. So then we have a negative number here. So here it's negative. And then let's find what f prime of 0 would be. F prime of 0, e to the 0 times 1 plus 0. So it's just e to the 0 or just 1. And this is a positive number. So it's positive on this side. So if it's negative on this side and positive on this side, that means the graph is going downward and then upward here. So at -1, we have a relative minimum. So relative minimum at x equals -1. And if you want to find the y value, we can just evaluate f of -1. F of -1, so -1 times e to the -1. Probably can't get a really exact value, so we'll just leave it like that. So relative minimum at -1 and -1 over e. All right, let's just go through, let's go over one more application so we can see how we can interpret this in a real life scenario. So here we have the projected population, y in thousands, some people we're talking about, and thousands of California from 2015 to 2030. And so we're saying the population can be modeled by this equation, y equals 34,696 times e to the 0.0097 t, where t represents the year and t equals 15 corresponds to 2015. So what rate will the population be changing in 2020? Okay, so remember, this gives you the population. So if we're trying to figure out the rate of the population changing, you want to find y prime. And we have a specific year we want to figure it out as. We want to find y prime at 2020. We want to find the rate of change in the year 2020. Now, if t equals 15 corresponds to 2015, that means if 2020 will be t equals 20. So then we want to find y prime of 20. So let's first find out the derivative for y, and then we plug in 20 into our derivative. So let's find y prime. Y prime will be 34,696 times e to that whole thing, 0.0097 t. So remember, this stays the same, and our composite function, our function is that we want to multiply this by the derivative of 0.0097 t. Because remember, if it helps, maybe think of this again as 34,696 e to the u. So we want to then multiply to find y prime. If u is that, it would be e to the u. Y prime would be this times du dt. Sometimes I don't even write this that much or use it that much because it becomes actually kind of easier just to remember this. Because writing it can sometimes make it more complicated. But always keep the expression and multiply it by the derivative of the exponent. So then the derivative of the exponent is just simply 0.0097. So let's see what we get. 0.0097 times 34,696. And so we'll get 336.55112 e to the 0.0097 t. Okay, and then if we want to find y of 20, let's evaluate this at 20. So we're going to basically plug in 20 into there. So we're going to have 336.55. 112 e to the 0.97 or 0.0097 times 20. Let's see what we get. So 336.55112 e to the 0.0097 times 20. And hopefully I didn't make a mistake. And I got 408. Yeah, 408.60. 55609 we're talking about is in thousands. So the rate is changing at approximately 408.6 thousand people per year. All right, and there you go. That's all there is to it.